morning, students. In this class, we see ampere circuit law. How can you find the magnitude of magnetic field due to straight conductor at a certain distance, and working of solenoid and working of toroid? These things we will learn in this focus in this class. So first we see Ampere's circuit law. Ampere's circuit law. Ampere's circuit law. This Ampere's circuit law states that the line integral of magnetic field at any closed surface is equal to mu naught times the net current passing through the surface enclosed by that closed surface. Once again I am repeating, the line integral of magnetic field at any closed surface is equal to mu naught times the net current passing through the surface. The net current passing through the surface. So mathematically it is represented by integral V bar dot dl bar is equal to mu naught times net current passing through the surface. It is given as integral B bar dot dl bar is equal to mu naught I, mu naught times net current. So first we see the proof. Now here I am taking on closed path. This is the conductor. This is the conductor. From this conductor, current I is passing. Current I is passing. Now I am taking one point, namely P. Its distance from the conductor I am taking as a. Now the line integral of magnetic field around any closed path, this we have to take integral B bar dot dl bar. So before going to that one, first of all we have to find the magnetic field at this distance. How much it is? B is equal to mu naught ni mu naught I by, we can take it as a 2 pi a, because a is the radius and this standard equation we can get. So magnetic field at this particular point I can get B is equal to mu naught I by 2 pi a. Now I am taking the equation, that line integral of this closed path I am taking the equation like this. Integral B bar dot dl bar is equal to, because it is a dot product. Dot product means we can get cos theta. So we can get integral B dl cos theta. Suppose if the theta is equal to 0, then cos theta becomes cos 0 is equal to 1. So that is the reason you can get integral B into dl. What is the value of B? The value of B is mu naught I by 2 pi a into dl. Suppose if I am taking mu naught I by 2 pi is common, then it will be like this. Mu naught I by 2 pi a is equal to integral dl. What is the total length of this element? The total length is nothing but circumference. So in place of integral dl, I can substitute 2 pi a. That is mu naught I by 2 pi a into, it will be 2 pi a, this 2 pi a cancelled. So finally I got mu naught I. So finally integral B bar dot dl bar is equal to mu naught times net current passing to the surface, any closed surface. So once again, all of you see the statement and proof. See, the Ampere circuit law, it states that the line integral of magnetic field due to any closed surface is equal to how many times net current? The mu naught times net current which is passing to the surface. So this is is the statement. Integral b bar dot dl is equal to mu naught I. Now at this point, now here I am taking one conductor. Around the conductor I am taking one circular path. Now here P is the observation point and A is the distance. Now I is the current which is passing through. Now at the point P, magnetic field is given by B is equal to mu naught I by 2 pi A, and integral B bar dot dl bar is equal to integral B dl cos theta or integral B dl, or that is you can take it as a, in place of A I can substitute mu naught I by 2 pi A into dl, and if I am taking mu naught I by 2 pi as common, integral dl, and finally got integral b bar dot dl bar is equal to mu naught I. Now by using this Ampere circuital law, how can we find the magnitude of magnetic field due to a straight current carrying conductor? Suppose here I am taking one conductor, it is carrying current I. Now my aim is to find the magnetic field due to the straight current around the conductor, like this. Now here I am taking one particular point, that particular point I am taking, this distance is A, the particular point I am taking as a P. Then how can we find the magnetic field at the point P due to this straight current carrying conductor? Simply the answer is, again we have to use this Ampere circuital law. What is Ampere circuital law? Ampere circuital law is nothing but the line integral of magnetic field due to any closed path is equal to how many times net current? Mu naught times net current passing through the circuit. Now here I have to apply the same Ampere circuital law for finding the magnitude of magnetic field at this particular point. How much distance is there between conductor and observation point? A is the radius. Now here I am using Ampere circuital law. What is Ampere circuital law? Integral B bar dot dl bar is equal to how many times net current? Mu naught times net current passing through the circuit. B bar dot dl. B bar dot dl is nothing but B dl cos theta. B dl cos theta is equal to mu naught times I. If both are parallel means cos theta is equal to 0, and simply you can get integral B dl is equal to mu naught times net current I. Suppose if I am taking B is common, B integral dl is equal to mu naught times I. Now B into the total length is nothing but 2 pi r, so I can take 2 pi a is equal to mu naught times I, and finally B is equal to mu naught I by 2 pi a, that I can get. So see the simple derivation. By using this Ampere circuital law, how can we find the magnitude of magnetic field due to a straight current carrying conductor? So here the straight current carrying conductor, it carries current I. Now my observation point is at point P at a distance A from the observation point. Now according to Ampere circuital law, I can get integral B bar dot dl bar is equal to mu naught times I. Now B it is a dot means it will be B dl cos theta. Both the elements are parallel, that is the reason B dl cos 0 value 1 mu dl. So B into dl, if I am taking B is common, integral dl, total length is nothing but circumference, so that is the reason in place of that one I take B into 2 pi a is equal to mu naught times I, and finally B is equal to mu naught I by 2 pi a. The next concept is solenoid. in examination point of view, solenoid and toroid both are very useful because they are giving frequently those two questions asking again and again. So see the explanation and derivation part. See, solenoid is nothing but, if I am taking one insulated wire, if that wire is bending like this and this is act as a one solenoid. If I am testing that insulated wire by using number of turns, if it is wound like making number of turns, and this is acting like a solenoid. Now here each turn is behaves like a one circular loop. Now here it is one circular loop. This is the second one. This is the third one. This is the fourth, fifth, sixth, seventh. Like this, 7 circular loops are there. So each one is behaves one circular loop. Each turn is behaves like a one circular loop. Then, if I want to find the total magnetic field due to this solenoid is nothing but we have to add vector sum up. That means the first one, second one, third one, fourth one, fifth one, sixth one, second one. Thus all these magnetic fields we have to sum up. Then only we can get the total magnetic field due to this solenoid. Now the same diagram here I'm redrawing. I'm taking one coil. See, here number of turns are moving like this. Suppose here this is upward, this will be downward. Now in that one I am taking one small portion of the solenoid. In this portion, 4 parts are there: AB, BC, CD and DA. Now if we want to find the total magnetic field due to this solenoid, then I have to sum up these 4 parts. By using Ampere circuit law, I can get integral A to B bar dot dl bar plus integral B to C B bar dot dl bar plus integral C to D B bar dot dl bar plus integral D to A B bar dot dl bar. See the 4 parts: AB, BC, CD and DA. The first part, integral A to B bar dot dl plus second one BC B bar dot dl and third one BC and third one C to D and fourth one D to A. But here one important point you must note: the line integral of B to C and the line integral of D to A. In these two cases, the B and DL both are perpendicular. If the both are perpendicular means BC element and DA element, both B and DL are perpendicular. Perpendicular means BDL cos theta. Here also BDL cos theta you will get, but cos 90 is nothing but 0. So that is the reason this BC element and DA element both becomes 0. Why it is becomes 0? Because here the B and DL elements are perpendicular to each other. So that is the reason the both the elements are 0. And one more element, this CD element is also becomes 0 because it is lying outside the solenoid. Outside the solenoid means there is no charge. So that is the reason here also there is no magnetic field. That is the reason there also the integral B bar dot dl value becomes 0. Then the the part which is lying inside the solenoid, that only you have to consider. What is that one? A to B. So finally, integral A to B, B bar dot dl bar we have to consider. That is equal to mu naught times I. Mu naught times I. Now here I have to solve all these things. So integral B dl cos theta. Here I can take it as a cos theta value, theta is equal to 0. Then finally I can get integral B dl. Integral B dl. Then later, if I am taking B is common, integral dl is equal to mu naught times I. And finally I can get BL is equal to mu naught times I. BL is equal to mu naught times I. This is for single term. If it has n number of terms, then it will be BL is equal to mu naught times NI. Then that capital N I can write small n into L. That is the total number of terms is nothing but the total number of terms is nothing but number of terms per unit length into L. So there you can substitute the value. So BL is equal to mu naught into NL into I. This L and this L cancel, and finally B is equal to mu naught times NI. So what is the small n and what is the capital N stands for? This is small n is nothing but number of turns per unit length, and this total capital N stands for the total number of turns in the solenoid. So once again, all of you see the diagram and derivation part of this solenoid. A solenoid is nothing but an insulated wire. If that insulated wire is turning on the conductor and that winding on the conductor, then that behaves like a solenoid. Now each turn behaves like a one circular loop. Now here one circular loop, here one circular loop, here one circular loop. Now if you want to find the total magnetic field due to this solenoid, we have to sum up the magnetic field due to individual circular loops, then we can find the total magnetic field. Here one part of the diagram here I am taking. Now here one particular portion. Now A, B, B, C, C, D, D, A. Now here I am applying Ampere circuit law. What is Ampere circuit law? The line integral of magnetic field due to any closed path is equal to how many times? Mu naught times the net current passing through the circuit. So that is the reason here I am applying Ampere circuit law for different elements A, B, B, C, C, D and D, A. But here the elements due to B, C and D, A both are become 0. Why it is 0? Because both are perpendicular. B and D elements are perpendicular. So that is the reason both are becomes 0. And the element CD is also become 0 because it is lying outside the circuit diagram. Only element AB is we have to consider. So according to the statement, here we have to take the statement. Then later, then we have to substitute BDL cos theta, BDL, and the total length is L mu naught I, and BL is equal to, if n terms, if it is mu naught I, and the later I will substitute, and finally like what? The magnitude of this solenoid I can get B is equal to mu naught NI. And the next we will discuss the toroid. See, the solenoid is like this. If you wind and the coil, then it will be formed. The solenoid is bent in the form of circle. The solenoid is bent in the form of circle, and that behaves like a toroid. This is the solenoid. If that solenoid is bent in the form of circle, and this is behaves like a toroid, and this behaves like a toroid. But here and each and everywhere B and DL are parallel, so that is the reason everywhere it will be same. Now here also I am applying Ampere circuit law. integral b bar dot dl bar is equal to mu naught times I. Integral b dl cos theta is equal to mu naught times I. Cos theta, theta is equal to 0. Everywhere it is constant, so that is the reason everywhere it will be same. So simply you can get integral b dl is equal to mu naught times I. If I am taking b, it will be dl is equal to mu naught times I, and b into what is the total length? Total length is nothing but circumference. So there you can take it as a 2 pi r into mu naught times I. Suppose if I am taking n turns, it will be b into 2 pi r is equal to mu naught times n into I. So in place of n, I can take small n into 2 pi r. That value you can substitute. So b into 2 pi r is equal to mu naught times n into 2 pi r into I. So this 2 pi r and 2 pi r cancel. So finally b is equal to mu naught n I. So once again the result is same. The result is similar to that of solenoid. So once again you see the explanation. The toroid is nothing but the rounded shape of solenoid. This is the solenoid and this is the toroid. Now here everywhere on the toroid the length of the element B and DL both are in the same direction. So that is the reason here I have to apply Ampere circuit law. Ampere circuit law is nothing but integral B bar dot DL bar is equal to mu naught times I. So BDL cos theta is equal to mu naught times I. Cos theta is equal to 0. That is the reason I got BDL is equal to mu naught times I. B into integral DL is equal to mu naught I. So here the total length of the element is nothing but the circumference. So that is the reason b into 2 pi r is equal to mu naught times I. So b into 2 pi r is equal to, if it is single term, here if I am taking number of turns, it will be mu naught times ni. So the total number of turns is equal to n into number of turns per unit length into 2 pi r. Then finally you can get b is equal to mu naught ni. So finally you see the results. So the solenoid and the toroid, both the results are same. So b is equal to mu naught times ni. So n, the small n stands for number of turns per unit length. I is the current passing circuit, B is the magnetic field, and solenoid is also the equation is same.